Okay, so this is part 3 of in class 9. So we left off finding the variance. Let's get going here. So the 4 times probability x is 4, 5 times probability x is 5, and lastly 6 minus 26 over 7 squared times x equals 6. This would be our variance. Okay, so let me just take this again and paste it below over here. Oh, not the whole thing, just here. Okay, so the probability x is 0. You can check up the top there. We found that was 2 over 182. Probability x was 1. Again, looking up the top, that was 12 over 182. Probability x is 2. That was 22 over 182. We found these values in the last video. Probability x is 344 over 182. Probability x is 4. 4 was 42 over 182. Probability x was 5, was 40 over 182. And lastly, probability x was 6. You can check, it was 20 over 182. Okay, so then this equals, now let's do, say, the first one here. So let's go to the calculator. So it'll be parenthesis 0 minus 26 divided by 7, close parenthesis, then raised to the second power multiplied by 2 divided by 182. So equals, so 1516, I'll round it to the first 4 places, say. So coming back over here, we'll put down here 0.1516, and you go through and you do it for the next one in the calculator. I won't go through that, I'll just give the answers you should get here. It's 0.4857, and the next one would be 0.3552, the next one would be 0.1233, next one would be 0.0188, next one would be 0.3633, next one, and last one would be 0.5741. And then if you add these guys up, you can check it's roughly equal to 2.07. Okay, so that's our variance. So the standard deviation will equal sigma which will equal the square root of our 2.07, and you can check that that roughly equals, get your calculator, roughly equal to 1.41. So 1.44, sorry. So we're done with question 1. Let's go down to question 2. So suppose that there are two groups of 5 players. Our game has 3 rounds. Okay, in the first round, 2 members of the group are randomly chosen for the second round. In the second round, 2 of the 4 remaining players are randomly chosen for the final round. In the final round, 1 of the 2 remaining players is randomly chosen to win. Suppose each player pays $7 to play the game. Moreover, suppose a player wins $11 if they make it to the second round, but not the final, $19 if they make it to the second, if they get second place, and $27 if they win. So mathematically analyze this game to determine if it is in your financial interest to play the game. So first thing to note here is, let's look at our random variable. So our random profit variable let's call it X, takes on values. Well, if you lose $7 because that's how much it costs to play. If you make it out of the first round, you win $11, but you paid $7 to play, so you made a profit of $4. If you make it to final round, you make $19, but you cost $7 to play, so you made a profit of $12. And if you win the game, you win $27, but it costs you $7 to play, so you've won $20. Okay, so let's look at our expected value of a random variable. That's going to be -7 times probability you do not make it out of first round. So do not make it out of first round, plus 4 times probability make it to second round, make it to second round, but not final, plus 8 times 12 times 12 times plus 12 times probability you get second place, plus 20 times probability you win. So note here, so probability, so this will equal then, so it equals here, be -7 times, now probability you do not make it out of the first round. Well, only 2 people out of the 5 make it out of the first round, so that means 3 people do not make it out of the first round, so 3 out of 5, plus 4 times, now the probably you make it to the second round, so it means you made it out of the first round, so there's 2% chance you make it out of the first round, but not to the final. So to make it to the out of the next round, we don't make it out of round 2. Well, there's 4 people in round 2 and 2 people make it out, that means 2 people do not make it out of round 2, so be 2 out of 4 here. Plus 12 times, so probability you make it, you get second place, that means you made it out of the first round. You made it out the second round, it's 2 out of 4. And you lose, so you're not chosen as a winner, so there's only 2 left, so you're not the one chosen, so there's a 50% chance you aren't chosen, so be that. Plus last guy 20, so you make it out of the first round, 2 out of 5. Actually, I messed up in this one. There should have been 2 out of 5 here. 2 out of 5. So 2 out of 5 chance you make it out of the first round. 2 out of 4 chance you make it out of the second round. And one half chance you make it to, you win. So it'll be this. Okay, so simplifying this, we got minus 7 times 3 would be minus 21. And here that 2 on top will cross off, the 4 on the bottom will become a 2, so it'll be 2 over 2 here, which will be 1. So just become 4 in that one. So let you check when you simplify across here. Look at that, which ends up being negative 1 over 5. So it's negative our expected value. So therefore we can say, hence the expected value is negative, so it is not in our financial interest to play the game. So in particular, if we play the game many times, on average we would be losing 1/5 of a dollar per game. So 1/5 of a dollar would be 20 cents per game. So if you play the game many times, you would be losing 20 cents per game. So and again up here, for example, looking at this one, I claim that will be the 6 here. So you can see if I did the 2 here, the 4 here, that cross out, and this become a 1, this guy. So you'd have 12 left. But you're multiplying it by half here, so the 2 into 12 equals 6, that's how I get to 6 here. And so forth. So we're done.